This is your Module 4 review, and it's designed for you to pause the video, work through the questions, and then check the solutions. Alternatively, the blank PDF of all of these questions is in the video lesson section, as well as the solutions, so you could work on it on your own and then check the video for ones that you got wrong. It's up to you. We'll begin with conversions. We're going to start with imperial conversions, and we're going to begin with how many feet are in 5 yards. So what we're doing is converting from yards to feet. So we're going from a big unit to a small unit, therefore we're going to multiply. And we look in our conversion table and we see that 3 feet is equal to 1 yard. So we're going to take 5 yards and multiply by 3. So we'll get a total of 15 feet. For B, how many seconds are in 6 minutes? We're going from minutes to seconds. So again, we're going from a big unit to a small unit. So we'll multiply. And there are 60 seconds in 1 minute. So we're going to multiply by 60. So we're going to take 6 times 60, which will give 360 seconds. For C, we're going to convert 60 inches to feet. So this time we're going from a small unit to a big unit. So we're going to divide. And we look up in our conversion table and we see that 12 inches is equal to 1 foot. So we're going to divide 60 divided by 12 is equal to 5 feet. And for our last one, we're going from yard to feet, and we've done this one before. We're going from big to small. So we're going to multiply, and we see 3 feet in 1 yard, so we'll multiply by 3. So 8 times 3 is 24 feet. Here, a 36-ounce can of coffee is on sale at Jerry's Foods for $7.89. What is the cost per pound to the nearest cent? What I recommend here is that you first convert 36 ounces to pounds. Because we're going from a small unit to a big unit, we're going to divide, and there are 16 ounces in 1 pound, so we're going to divide 36 by 16. And what that gives us is 2.25 pounds. Now we can convert to a unit rate. So if we're paying $7.89 for the whole can, we can divide by the quantity in the can. So money divided by quantity is going to give us our unit rate, or the price per pound. So when we divide, we're going to get $3.51 per pound. Now we'll look at metric conversion. It's really quick if we use our metric line. So we're going to be sliding our decimal right or left depending on which direction we're converting. So for number A, we're converting kilometers to meters. So we're going to be going to the right 3 decimal places. So this will equal 5,702 meters. For B, we're going from centimeters to meters, so this time we're going to the left 2 decimal places, so this will equal 0.695 meters. For C, we're going from centimeters to millimeters, we're going to the right 1 decimal place, so this will equal 81 millimeters. And for D, we're going from meters to millimeters, so we're going to the right 3 decimal places. So this requires us to add a 0. So 1, 2, 3. So it's 1,280 millimeters. We'll continue converting with metric. This time we're converting volume. So we're going from 2.5 liters to milliliters. We're going to the right 3 decimal places. So this means we're going to be adding 2 zeros, 2,500 milliliters. For B, we're going the other way. We're going milliliters to liters, 3 decimal places. So we'll go back and we'll add 1 0 before the decimal. So this will be 0.08, and you can drop that last 0 so 0.08 liters. For C, we're converting liters to centiliters. That's to the right, 2 decimal places. So we're going to be adding 2 zeros. This will be 5,000 centiliters. For D, we're converting liters to kiloliters. So this time we're going to the left, 3 decimal places. So we'll go backwards 3 places, filling in with a 0. So this will be 0.0186 kiloliters. Units of mass work exactly the same way as length and volume. So this time we're converting grams, milligrams to grams. So we're going 3 decimal places to the left. So we're going to be adding in 3 zeros. So this will be 0.007 grams. And when we are going from kilograms to grams, we're going to the right 3 decimal places. So we'll be adding 1 zero at the end. This will be 13,720 grams. For this word problem, Ruben measured a board and found that the length was 3 meters plus an additional 5 centimeters. He cut off a piece measuring 1 meter, 40 centimeters for a shelf. Find the length in meters of the remaining piece. So we have 2 methods we can use here. The first method is to keep everything in meters by converting the centimeters. So method 1, which would be 3 meters, and then the 5 centimeters to go to meters would be 1, 2, 3 decimal places. So this would be 3.005. Pardon me, that's actually incorrect here. So I'm just going to erase. I'm going from centimeters, not millimeters, only 2 decimal places. For these questions, we're converting within metric and imperial between the 2 measurements. So for the first one, we're converting 18 gallons to liters. So we're going from the US customary or imperial system to our metric system. So we're going to be looking on the right-hand side. And we are going to where the conversion is. 1 gallon is 3.79 liters. So we're going to take 18 and multiply that by 3.79. And when we do that, we're going to get 68.22 liters, but they want us to round the answer to the nearest tenth. So our final answer will be 68.2 liters. For the next one, we're converting 300 grams to ounces. So this time we're going from metric to imperial or US customary. So we need to find our gram to ounces, which is down here. So we're going to take 300 grams, multiply that by 0.035, and we are going to get the tenths place right away, so 10.5 ounces. Now we're moving to the geometry portion of our unit, and we're going to identify some figures, and we're going to name them. So for A, we have a segment, and a segment is defined as having 2 endpoints. You can write a segment 2 ways. You can name the segment as BC, showing no arrows above, or CB. So that's how we identify the segment. B, we have a ray, a point or an endpoint, and an arrow going upwards. So a ray can only be named one way, and it's from the direction of the point outwards. So this ray is BA. For C, we have a line. We have arrows on both sides, and lines can be identified and named 2 ways. So we can name this ED, showing the arrow symbols above, or DE, pardon me. Now we can look at lines and decide if they're parallel or intersecting. Remember, parallel lines are lines that are on the same plane. They don't have to be perfectly aligned with one another, but they will never touch. It's never 100% possible for us to know, but we can assume that these first ones are parallel, that they won't cross each other. For B, we can clearly see these lines are crossing each other, or what's known as intersecting. And for C, even though we don't know 100% sure until we see the symbols for parallelism, we can assume that these lines are also parallel, that they will never cross. Now we're going to name the angle in 3 different ways. So we can see that this angle has G as its vertex. So we can call this EGF, going from E to G down to F. Or we can call it the other way, going from F upwards, FGE. Or we can name the angle by the number that they've assigned to it, angle 2. Now we're going to label each angle as either acute, right, obtuse, or straight. We see A, we're on perfect straight line, that's 180 degrees. This is a straight angle. For B, this is a small angle, less than 90 degrees. It's acute. For C, the angle is large. It's greater than 90 degrees. This one is obtuse. And for D, we see the telltale right angle in the corner, 90-degree angle. This is our right angle. Which pairs of lines are perpendicular, A or B? What's critical for us to know is that perpendicular lines are intersecting lines, but they're special ones, that they have to cross at a right angle. They cross at 90 degrees. So A, because of our 90-degree angle, proves to us that these 2 lines are perpendicular, whereas B, we can see that they're not crossing at 90, but we have to be shown that symbol to know for sure. So B are intersecting lines, but A is perpendicular. The next section is about angles that are paired together. So 2 angles are called what if the sum of their measures is 90 degrees. So these 2 angles are called complementary. So how we solve a complementary angle is to subtract from 90. So for A, when we want to find 32 degrees complement, we're going to take 90 minus 32. When we do that, we're going to get 58 degrees. For B, we want to find the complement of 65 degrees. So we take 90 and we subtract 65 degrees. And when we do that, we get 25 degrees. Now the angles that go together and make the sum of 180 degrees are called supplementary angles. And you can remember these 2 by the beginning letter, that C means corner or 90 degrees, and S means straight or 180 degrees. So if you want to find the supplement of 84 degrees, you need to subtract from 180 degrees. So we're going to take 180 minus 84, and that's going to give a result of 96 degrees. So 84 and 96 degrees are supplements. For 135 degrees, we again take it away from 180 to see what its supplement is. And when we do that, we get a 45-degree angle. In this figure, we're going to find the measure of every unlabeled angle. And what we're first going to do is look for those vertical angles, those angles that are directly across that are equal angles. So our first angle here is 36 degrees. So that means across from it is 36 degrees. So angle AGB is 36 degrees. And then angle AGF is 116 degrees, so its a vertical angle pair, the one across from it, CGD, is also 116 degrees. So now what we need to do is solve for one of these missing angles. So observe that this angle plus the 116 plus the 36 is going to equal 180 degrees. So if we want to solve for this angle, for angle FGE, this one here, then we are going to take 180 degrees on the straight line, and we're going to take away the other two angles. We can either add those two angles together and take away once, or we can take them both away on our calculator. So when we do that, we're going to come out with a result of 28 degrees. So this FGE angle is 28 degrees, and that means that the angle across from it, its vertical angle, CGB or BGC, this one is also 28 degrees. So we can use our knowledge of vertical angles and angles on a straight line to solve for missing angles in a figure like this. We also learned that triangles are composed of three angles, and those three angles added together always equal 180 degrees. So as long as we have two angles, we can solve for the third. So what we want to solve right here is angle C. So we're going to say that angle C is equal to 180, and we can take away the other two or combine the other two and take away once. Okay, so you can show it as subtraction, or you can show it as subtracting 44 plus 29. Whichever way you go about it, angle C is 107 degrees. It's an obtuse angle. For angle D, we see that we've been given information for angle E and angle F. So angle E is 90 degrees, and angle D we are solving for. So angle D is 180 degrees, minus 90, minus 37. So angle D is 53 degrees. Once we got through the angle section of this module, we got into shapes and using our formula sheet to calculate perimeter and area. I strongly encourage you to write the formulas down every time you use them. That way you get better and better at remembering the formulas, and you're less likely to make mistakes. So if we want to find a perimeter of this shape, which is a rectangle, then we're going to see that we take 2 of the lengths plus 2 of the widths. So we basically add all our sides together. But I'm going to use substitution. 16 is my length, and 6 is my width. Remember that using substitution is a skill that you're going to need in future math, so it's good to practice it now, even if it takes you longer. So the perimeter is going to be 32 plus 12. So we're looking at a perimeter of 44 meters. And remember, it's a linear, the length all the way around this object. If we want to find the area, it means we're figuring out how many little squares, perfect 1 yard by 1 yard squares there are in this rectangle. So we use the formula for a rectangle, which is length times width. So the area is going to be 15 yards times 7 yards. And because we're multiplying yards times yards, we're going to get yards squared. So we get 105 square yards. So there's 105 little squares inside this figure. For A, we want to find the perimeter of a square where each side measures 7 meters. So I usually draw the figure just so it gets me visualizing it. So this is 7 meters all the way around. I have a formula for perimeter of a square. The perimeter of a square is 4 times the side. So we know the one side is 7. So we're going to substitute and calculate our perimeter as 4 times 7, which is 28 meters. If we want to use that same square and calculate the area, still 7 meters, we use a different formula. Area is the side squared, which is length times width, but remember, using the formula will really help you later on. So the area is going to be 7 squared, and squaring means multiplying by itself, so this is 7 times 7. The area is 49, and it's meters squared because we're multiplying 7 meters times 7 meters. These next two figures are what we learned after rectangles and squares. The first one is our parallelogram, which is just a tilted rectangle, and our second one is a trapezoid. For this first one, all we can calculate is the perimeter, because if we want to calculate the area of a parallelogram, they need to give us the height. The 9 centimeters is not the height. So because they didn't provide that for us, we're just going to calculate the perimeter here. The perimeter of a parallelogram is the same as a perimeter of a rectangle. So we're going to take 2 times the 15 plus 2 times the 9. So that's going to be 30 plus 18. So our perimeter is going to be 48 centimeters. For the trapezoid, if we wanted to calculate the perimeter, we'd simply add up all the sides. For this one, we're going to focus on the area formula, which is the height multiplied to the 2 bases, and the bases are the ones that are parallel lines, so 7 and 13 will never cross. That's how we know the bases. And then we're going to divide that all by 2. They've provided us with the height, which is 8 meters. So we're going to take 8 multiplied to 13 plus 7. Remember, we must do the brackets first, divided by 2. So that's going to be 8 times 20 divided by 2. So that'll be 160 divided by 2. The area is going to be 80. And in this case, the units are squared meters. For the perimeter of a triangle, we're simply going to add all the sides. So we're just going to take the 20 plus the 16 plus the 12. So that's going to give us a perimeter of 48 feet. For our area, the formula is base times height divided by 2. Now, how do we know the base and the height? They need to show you a right angle if the triangle is not a right triangle. But if it is, as in this one, we use the right angle to give us our base and height. This hypotenuse, or the diagonal, is never used for calculating the area of a triangle. So our base and height, base is 16, height is 12. And it really doesn't matter if you oriented it and changed that. You're going to have 16 times 12 divided by 2. And when we do that, 16 times 12 divided by 2, we're going to get 96 square feet. Now it's time to review circles. For circles, we have to understand some vocabulary, that the radius is from the central point out to the edge of the circle, and that the diameter is fully across a circle, and that if you have 2 radius, that equals the 1 diameter. So if you want to solve the diameter and you're only given the radius, you're going to multiply the radius by 2. And if you want the radius and you're only given the diameter, you're going to cut that diameter in half. So we'll practice that skill here, where we only know one of the units and we need to solve for the other one. So in this case, we are given the radius is 12 inches, but we don't know the diameter. So we do know that the diameter is equal to 2 of the radius. So we're going to multiply 2 times 12. So the diameter will be 24 inches. For B, they've told us the diameter is 7 meters, but we don't know the radius. The radius is the diameter cut in half. So we're going to take that 7 and divide by 2. So the radius is going to be 3.5 meters. So let's review the 2 formulas that we use for circles. The first formula is circumference, which is perimeter. That's your outside measurement of your circle. And the formula is pi times the diameter. Now we use rounded pi. It's much easier for us than using maybe a pi button if you don't have that on your calculator, because pi is a decimal that never ends. So we're going to use 3.14, and here they've given us the full diameter of 24 meters. So we're going to multiply 3.14 times 24 in order to find the outside measurement of this circle. And that is equal to 75.36 meters for our circumference. If we want to measure the inside of the circle, how many squares are in there, we're going to use the formula pi r squared. So we need to keep these formulas straight in our mind and use our formula sheet often. So this means we're going to have 3.14 times the radius, but they only gave us the diameter of 24 meters. The radius is the diameter cut in half. So this is going to be 24 divided by 2. Oops. So the answer here is going to be 12. So our radius is 12, and we're going to square that. So 12 squared is 12 times 12, that's 144, and then we multiply that to 3.14. And so we're going to end up with an area of 452.16 square meters. And you may want to write this out for yourself when you're squaring, just to keep things straight. 3.14 times 12 times 12 can really help you to avoid making mistakes when squaring. The biggest mistakes that I see are either multiplying by 2 instead of multiplying by itself, or adding itself, 12 plus 12. We don't want to make those mistakes with squaring. For partial shapes, you need to be really careful and read the question carefully what they require. First, I'm going to show you the area here. So if we want to get the area of a half circle, we're going to cut our formula in half. So we're going to use pi r squared, but then we're going to divide our answer by 2 because we only have half a circle. So we're going to take 3.14 times 9 squared, and then divide that by 2 after we solve the numerator portion. So 3.14 times 81, which is 9 squared, divided by 2 gives us an area of 127.17 square feet. When you have partial shapes, it's actually sometimes more difficult to calculate the perimeter because there's something easily forgotten. If we wanted to calculate the perimeter of this shape, what this means is we're getting half this circle, but this circle is not attached to another shape. So we actually have this full diameter that we need to add on as well. So we are going to take pi times the diameter and cut that in half for the outside edge of the circle, But then we're going to add the diameter for this straight piece. Well, this is a little beyond our course. You'll do this more in the next level, but it's good to show it now. So we're going to take pi 3.14 times the diameter. Now remember, they gave us the radius of 9 feet. So the diameter is 2 times the radius, so 2 times 9. So the diameter is 18 feet. So we need to multiply by 18 and then divide that by 2. And because the diameter, this full distance here, is 18, we're going to add that on as well. So we'll do that at the end. So we're going to take 3.14 times 18 and divide that by 2, and that's going to give us 28.26. And then we'll add the 18 on. So our total perimeter, the outside measurement of this semicircle, is 46.26 feet. Word problems come with the geometric shapes. So we have a circular rug. So we draw a circle, best we can, and it's 10 feet in diameter, so all the way across is 10 feet. The cost of fringe for the edge, so this is our clue, we're just dealing with the edge or the circumference of the circle. The cost of that edging is $3.20 per foot. What will it cost to add fringe to the rug? Okay, well, first of all, we need to know the outside, the length, the circumference. So we're going to calculate by pi times the diameter. So we're going to take 3.14 for pi times the diameter, which they provided as 10 feet. So the circumference is going to be 31.4 feet. Now that we know the total distance, we can calculate the cost. We take our total distance, 31.4 feet, and we multiply this by the cost per foot, $3.20 per foot. When we do that, we are going to get the cost of $100.48 for adding that fringe to the rug. The last thing we learned are composite figures. Composite figures can be shapes within shapes, which require subtraction, or shapes on top of shapes, which require addition. You can also be asked for perimeter of composite shapes, and you need to be very careful to account for all sides. In this example, we see a single tick for 5 inches, and that same tick repeated over here. So what this means is that this measurement here is 5 inches. If we want to calculate our perimeter, we're going to simply add all the sides, and you can go in any order you want. I'm going to go clockwise. 5 plus 10 plus 15 plus 5 plus 7 plus 6. So for perimeter of composite shapes, you just make sure you've got all your outside measurements, and this is 48 inches. For the area of the composite shapes, you need to break the shapes up and use your formulas. So I've chosen to break this shape like this. I feel it is the best place. What this does for me is gives me a rectangle. So this is shape 1, let's call it, and a trapezoid, which is shape 2. So I'm going to then take shape 1 area, which is length times width for the rectangle, and I'm going to carefully look that the length is 6 inches and the width is 5 inches. So this is going to be 30 square inches for my rectangle. For the area of my second shape, it's a trapezoid because it has this kind of jutting side to it, and that side is not parallel to the other side, so the two parallel sides are the top and the bottom. This is 7 plus the 5. So in total, from one side to the other is 12 inches. And the bottom is 15 inches, so that's A and B. And for the height, I have to be careful here. The total distance is 10 all the way from top to bottom. So I'm going to take away the 6 up above. So I'm going to take the 10 minus the 6 over here, and that's going to be 4 inches for my height. So my height times A plus B divided by 2, that equals 4 times the 12 plus the 15 divided by 2. So I'm going to do this math. 4 times 27 divided by 2 is 54. And that's going to be 54 inches squared. And now I can add the two together. So the total area is equal to 30 inches squared plus 54 inches squared. So that's going to be 84 square inches for this composite figure. Best of luck on your Module 4 exam.